So about 3 weeks ago, Apple launched their new AR VR headset, which was called the Vision Pro. And the tech on that was absolutely insane. Like, they've been working on this for like the past 10 years. But for some reason, it still feels a bit incomplete. Why is that? So Apple in the keynote, they showed a lot of different ways in which the Vision Pro could be used. But for the most part, they actually showed the Vision Pro just displaying screens in your physical space, right? It's like the same screen that you would see on your computer or on your phone, just much bigger and in front of you in your space. And the question is that really the best way to actually do or approach AR? And to answer this question, we kind of need to understand human-computer interaction. To us, human-computer interaction is quite straightforward. We take in information from our environments, from our devices like our laptops, our computers, and our phones. And based on this information, we do things, right? We interact with these devices. Basically, on one hand, we have consumption of information, and on the other hand, we have interaction. Let's start with consumption. So for us to understand this concept of consumption, it's quite important to understand what information really means to us. And the thing is, information is literally everything. It is everything. It's the foundation of our reality. I mean, we have 5 senses, and all these senses are doing is they're relaying information to us. For example, when you touch something hot, all our senses are doing is relaying the information that that thing is hot. So everything is information. And the interesting thing is, humans are still hunters and gatherers. We used to hunt and gather food, but now we've come to the point where we're constantly looking and searching and trying to gather more information. There was basically a BBC study that was done where participants were put into a room where there was nothing in front of them except a button which would shock them every time they pressed the button. And it was so interesting to actually see that these participants would voluntarily shock themselves simply because it was some information that was coming to them. It was some stimulus that was causing them to feel or ingest some sort of information. And that's so crazy to think about. Even when we're bored, we're looking for information. We're looking for some sort of consumption of information. But what does this really lead to? I mean, with the tech explosion, we saw that all we were doing was just giving ourselves more access to information, like with mobile phones, with computers, with the internet. It's just information that is more readily available for us to consume, which is amazing. I mean, the world is at our fingertips, but at the same time that comes at a cost. And the cost is information overload. We are now actively trying to look for ways in which we can limit or suppress the amount of information that we consume. I mean, now we keep track of how much we actually use applications. We set automatic limiters on how much we can use these applications, and it's becoming a problem. Information overload is a genuine problem. And that's what I think that AR can really solve. And that's this idea of contextual information. I mean, it's trying to bridge the gap between the physical world and the virtual world, the digital world, more and more. And the craziest thing about that is that this idea of contextual settings and contextual environments start mattering more. And we can start building products and applications which deliver information contextually. But we'll get to that later in the video. In terms of human-computer interaction, we've come a really long way. In the 1950s, we literally used to use punch cards to interact with our computers. Then that evolved into slightly more sophisticated means of command line interfaces with keyboards. And then we had mice, which used pointers. And we've come to the point wherein we literally interact with our devices through touch and gestures, very sophisticated means which clearly show we're trying to bridge the gap between more primitive forms of interaction to more natural forms wherein we touch surfaces and we use gestures. I mean, that's how we communicate with people, right? I'm gesturing to you right now. We touch things to interact with them. So things are getting realer in a way. But how does this contrast with the real world? When we interact with things in the real world, we are calculating a lot of things as we interact when it comes to touch, when it comes to sight, when it comes to using our senses. Now, what is really interesting in this case is the feedback loop that is actually created. And in terms of human-computer interaction, what we're trying to reduce is the loss in terms of the feedback. And how that happens is when the device or when the computer actually gives us more information to interact off of. And that's what AR does so brilliantly. AR brings in depth. It adds another dimension to our perception, which in turn enriches the interaction itself. So of course there are two reasons why this depth actually matters in terms of enriching our experience. The first one is of course immersion. It feels realer. And the second is this idea of proximity, wherein our judgment in terms of our space is guided by how near or far things actually are. And that adds valuable context in terms of where we are currently and what we're doing right now. It is guided by our space, our movement, our motor skills, all are guided by how we move through spaces. And understanding proximity is really, really important for us to actually make decisions as we navigate through life. But how does that come back to the idea of information? It's quite clear how we've sort of established that the interaction is directly related to the mode in which we consume the information, and our perception of how rich the interaction is guided by the information delivery. The idea of contextual information is almost like when you enter a tourist city and you see a big board with different points and navigation routes and everything, and that gives you context on where certain things are, where certain tourist attractions are. That's contextual because that information does not have meaning outside of you being at that point, at that location. And if we think about this, that is directly guided by the idea of space and our spatial perceptions. It's established that there are two key aspects to AR. We have this immersion aspect to it. Then we have this spatial driven contextual information which we gain from augmenting our spaces. But what about Apple? In Apple's keynote, they didn't really touch upon that. They mostly focused on immersion and extending existing 2D displays, and that's kind of why it felt incomplete. And the thing is, I don't know if Apple is leaving this up to the developers, right, to take advantage of the fact that it has these capabilities. But right now, it really does feel incomplete. So how do we close this loop? How do we complete what we feel that Apple left incomplete? So sorry to cut off the video right there. We were actually planning to cover the approach in this video itself, but as we were doing our research, we realized that the topic is a lot more expansive than we initially expected. And that's exactly why we're going to be making another video covering only the approach. So stay tuned for that one. Thanks so much for getting till this point in the video. If you liked it, please do share, subscribe, and of course hit the like button. So Kubo is a startup which is working on building design tooling that is powered by AI from the ground up. We're also working on building our text to UI product where innovators can input text prompts and generate UI screens in real time. Apart from this, we also work with startups and other companies and help them reach their design goals. And if you find these topics interesting, please do consider subscribing. Also, if you like this background and camera angle better, please do drop a comment below. Thank you.